The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
Hello very good, everybody. My name is Samy Fodil. I will present you a new kernel module. Its name is DM Notify, and it's a device mapper module, and it will be used to do team provisioning from Userspace. So excuse me for my accent, and I'm not a native English speaker. And would you please, when you will ask questions, ask them slowly so I can understand you and answer the questions. Okay, first we have to understand what is team provisioning. So to do that, I would just explain that with a simple example using VMware Workstation. Perhaps a lot of people are used with this product. So when we create a virtual machine with VMware, of course we select the operating system. We can select Windows, Linux, and a lot of other systems. It's just VMware will set some settings. For example, for Linux, we'll set 1 GB for memory and other settings, default settings. And next, for the hard drive, we have the team provisioning hard drive. So if we look, if you look more closer, you will read this file start small and become larger as you add application files data to your virtual machine. So the file will start with 2 megs, and when we install a system on it, for example here it's a Red Hat Enterprise Linux. So we start the installation, and when we write change on the disk, we'll see the file growing. So it's 53 megabytes, and as the installation process goes on, the file becomes bigger. So it will be 400, 600, 800, 1 gigabyte, and so on. But for the OS, it's always 20 gigabytes. But really, it's not 20 gigabytes. This is team provisioning. So we have the OS, or the file system we have on our block device thinks he's in, for example, 20 gigabytes, but it's not really 20 gigabytes. One of the advantage of this feature is, for example, we could, have 5 VMs with 100 gigabytes each and store them in a file system with only 50 gigabytes available space. So this feature is very used in virtualization. So I've used VMware, but this feature is available in KVM QEMU, and you have just to use QCOW2 format for the disk or the VMware format. So you can use both, and QEMU will do the team provisioning for you. In this case, we have we have a little problem is that the VM goes through the file system layer and then the block device layer to access their blocks. So it's slower. Better if the VM goes directly to the block device. So to resolve this problem, we can use directly a block device, an LVM, a partition, or anything else. Any volume mapped with device mapper can be used. But the problem here is we're going to lose the tape provisional capability. So we'll have a volume of, for example, 20 gigabyte, and not a volume will grow as we use the file system. So hopefully we're on Linux and we can figure this out. So we can use device mapper and his functionalities. So I will begin to explain what's the device mapper. So the device mapper is a Linux kernel feature that will give us the possibility to make a virtual volume by mapping other block devices from other real or virtual disks. So let's suppose that we have 2 SATA disks and 2 iSCSI disks. So we have to create a logical volume and use all of them. And the problem is iSCSI is slower than SATA. So if we want to have the same speed of performance, we can have a stripping on the 2 iSCSI disks. So with device mapper, we can do that. So our volume is from linear mapping to the first disk. So if a process wants the first block, it will be linearly mapped to the first block in the first disk. And if the second will be the same, and the 2 iSCSI disks will be mapped with the stripped target. So we write 1 block here, 1 block here, 1 block here, 1 block here, so on. So we can read 2 blocks in the same time. See, so we have the speed increase by 2. So how we can do that with the command line? So we use the DM setup command line, and you can see so this code or commands will result in the virtual volume. So I will explain this in 2 separate slides to keep it simple. So D1 SZ is the size of dev SDB. D2 SZ is the size of SDC. D3 SZ is the size of iSCSI 1. D4 is for iSCSI 2. DI SZ is D3 plus D4, and DL SZ is T1 and D2. So all of those size, we get the size with block dev. Okay, I missed the C, so it's block dev get size, and it's the size of the device in sectors and not megabyte or byte. It's sectors. And then we create the table. So the table defines how the kernel will map the virtual block or a virtual block to a real block. So from the first block in the virtual disk or the first sector, to the size of SDB in sector, we have a linear mapping from SDB starting from the first sector. So it's just like we have SDB first. And the second line is we start from the size of SDB and we go to the size of SDC, and we map from the first sector of SDC. And it's just like we have SDB and SDC. And the second line is a shipped mapping. So we have DLSZ. So it's the size of the two first mapping. We start at this sector, and we map DISZ. It's a sum of the size of the two iSCSI disks. So we have a shipped target. So we'll specify the number of disks is 2, and size of a chunk is 64 sector. The first disks start from 0. The second disk starts from 0. So this will define the virtual volume, and we will have it's not exactly, but we can say it's the same speed, access speed. So I think at this point, everyone knows what's device mapper. And the second question is device mapper capable of theme provisioning? And the answer is yes. He's capable of theme provisioning by using the theme target as a module. It's a DM theme. And the DM theme target is the target that when we use this target, we can have theme provisioning. So how it works? So it defines a pool, and the pool, it's like in LVM, it's like a virtual it's like a VG, a virtual group. So in the virtual group, you have physical extent, and the LVM system will get the physical extent and create logical volumes. So in the pool, we'll use the pool and create 10 volumes inside the pool. So the pool is the source of provisioning. So we'll have this scheme. So this is an example. So we have the first volume. It's we have linear mapping and a thin mapping. So we will have linear mapping, 10 gigabytes pre-allocated, and 20 gigabytes provisioning, thin provisioning. And the second LV is all thin provisioning. And in the side of the pool, or inside the pool, we'll have blocks of LV1 and blocks of LV2. See, we have blocks in orange and blocks in blue. So, and the pool will allocate the blocks as we use the volume. So when we write in the volume, he will allocate blocks. Here we can see a problem. It looks like the fragment tool of Microsoft Windows. See, and it's the first problem. We have fragmentation. This is the first problem we have. So, and a pool can't be, or has a size limit is 16 gigabytes. So we can go for more, but we can create a lot of pool. Can create, for example, 2, 3, 4, 5, 10 pools, no problem. Another problem is that the pool will use the whole disk. I mean, if we use 16 gigabytes, it will be all for the pool. I cannot use the 60 gigabytes for a static volume, static LV. It can't be used. And what if the pulse runs out of space? A user space process, it's actually UDevD, will be notified, and we can add rules so we can grow the pool or do something else. So let's get an example of the DM theme. So the first step is to create the pool. This slide is just to see what we have to do, and it's quite readable. So I have 2 slides so to explain the procedure. So pool size is the size of the pool. Here I will use dev SDB as the source of the pool. ext size is the data block pool or physical extent size or data block size, and here in this example it's 4 megabytes. The meta size is the size of the metadata. So to store data, where is this block mapped to where, and this block is mapped to where. So DMT needs metadata. So metadata is calculated from this rule, and you can find this rule in the kernel documentation. So the metadata size in megabyte is this one plus 2 megabytes. So we create the metadata pool, and next we create the pool itself. So it starts from 0 to the pool size. It's the size of SDB. It uses the teen pool target, and it will use dev vol group empty pool as the metadata device, dev SDB as the backstore. ext size is the size of data block, and we have here the watermark. So if we use more than 80%, UDev will be notified. See, we can put here anything else, so can be more than 80, can be less. So, and then create a teen volume. So actually, DMTeen handle what might be handled by a user space program. So in the logic of device mapper, it's in user space, or we allocate blocks, or we define table in user space and not in the kernel. We load the table we have defined into the kernel, but we don't do that into the kernel. And DMTeen actually break this rule. So, and to create a thin volume, we have to send a message to the kernel through DM setup. So DM setup message dev mapper th pool, it's our pool, and create teen 0, and 0 is the ID of the teen volume. And using the teen volume, we will create a logical volume. So teen size, we have the teen size in megabyte, and we calculate the teen size in sectors. So we have to create it with this rule. So we start from 0, teen size, and the target is 10, and we will use the tin volume created in the TH pool with the ID 0. And at this point we have a provisioned volume with DM10. Yeah, and this volume will grow when we write on it through the real size. Yeah, and if I get back, the real size is the thin SZ. It's the real size. Yeah, but when we have a lot of tin provisioned volume in the same pool, it will be a mess, like the Microsoft file system. See, so it will be a mess, and the performance will be very bad. We can do snapshot with tin provision volume. If we use directly the device mapper target, it will be very bad for the performance. But the developers add the capability directly for the pool. So we can snapshot what we have in the pool, send in a message that create snapshot, and it will create snapshot. Yeah, so the DM10 is a pretty complicated solution, and it resolves a lot of problem, and it brings a lot of problem. So I have the idea to create something simple than the DM10. So why? If we consider the complexity of DM10 and the problem we have with this model, the model it's not yet stable. And to resolve this problem, I had to find a simple way to do that. So not the complicated solution of, DM10. Something as simple as the zero target. See, we read and we get zeros. Okay, we write that it will drop the write because we can't. It's always zero. So. After working hard to keep in a way complicated solution, because we human begins always by the complicated solutions. So the solutions come to me, and it's very simple. I have just to signal a user space process when an out of allocated space I/O comes. So if a process tries to read out of space, I have to send a signal to a process somewhere in the system, and the process will grow my volume. So, but I still have a problem. The problem is if a process tries to do that, I have an error, and the I/O will be dropped. So after dissecting the kernel device code, the kernel code it's not well documented, and it's not at all. You see, it's not very documented. So I found the requeue capability. So if we return the value 2 in our callback function that handles the I/O, the I/O will be requeued. So I also found how to suspend a device. Yeah, and I got everything I need to make it run. So I will, and this scheme will explain step by step how it will, how DM notify works. So we have notify D as a process that receives just a simple signal, a real-time signal. I use the real-time signal as to keep the model simple and to keep it fast. A real signal is faster than a TCP/IP connection or a queue or a shared memory or something else. So when we have an I/O to DM notify mapped block, so I map my linear blocks, for example, and then I have a part with mapped true notify target. The kernel will so the kernel will queue the I/O. You see in orange in the BIO queue. It's a basic I/O queue. It's what we use in device mapper. And it will ask the device table which target can handle this I/O. So the I/O will be handled by device mapper, and device mapper will be the callback of the device mapper will be executed, and device mapper will do these three simple tasks. It will suspend the device, send a real-time signal to notify D, and requeue the I/O. So we'll have the I/O requeued in blue. So we will notify first the process. We can't do it requeue and notify, because the requeuing will be done by the kernel when you return the requeue value. So we requeue, we send the signal, we requeue the I/O, and the notify D will wait, for example, 1 millisecond, because as I said, we can't requeue before sending the signal, so it have to wait, and then it will fork something, for example, a script or a program that will use, for example, DM setup to update the table and resume the device. So update the table means grow the device. So DM setup will update the table, resume the device, and the I/O will be resumed for the inside the kernel. But the I/O is in the last of the queue, so we have to wait until it becomes in the head of the queue. So DM linear, for example, when I have growth, it's linear. So DM linear will handle this I/O, and the process will resume his execution since the I/O is done. Yeah, and it will be the same if we try to write out of space, etc. Yeah. So if we let's get an example. So this is a simple example where I have a volume of, for example, 100 megabyte, and in the last I will put 1 megabyte of notify. So when the process will try to write in the notify, the volume will grow. Each time it will grow, and each time I will put the notify at the end. And I will grow by the size of notify. Now I can do whatever I want because it's in user space. I can, for example, if my host, which hosts a VM, run out of space, I can migrate the VM. I can do a lot of things because it's in user space. I can, for example, implement a garbage collector which runs and try to keep everything not fragmented like the Microsoft thing. Yeah. So I have 3 or 4 scripts. So the first is test create. So it will just create the volume, and it will be, you see, from 0 to base size, and it will be mapped to 0. So it's just an example, a simple example. And from this size to 1 megabyte, and I will map this one to notify. I will give him the PID of the notify D, since I will use a signal. The test grow will grow, so it will replace, you see in the third line, sed s/notify/0/. So the s is substitute, and it will replace every notify by 0. So the last notify, I have only one notify, the notify will be 0. And the echo, so the second echo will inject or add another notify at the end of the table. So I have my last table with the notify, change it to 0, and I have added a notify at the end. So I reload the map and resume the device. So because the kernel module, the mNotify suspended the volume. And test end is when we are at the max size. We can't grow more than that. The device will stop at this size. So it's the final size. We can't grow more than that size. And the master script is the script which will be called by notify D, and it will simply grow if the volume is less than the max, and it will stop the growing if the volume is more or exceed the max size. So let's get a demonstration. So okay, okay, so oops, I have to see. So we have first to create the volume. So it's very simple. So test create, called test1, and for example, this is the size in megabytes. And I have to give it the PID of the notify D. So here comes the PID. So to have the PID, I have to start the notify D. So yeah, notify D, start it, and PS grep. So So here the PID is of course this PID will be checked by the kernel module, so it works. And now I have DM setup table test 1. Now I have 0 and notify. See, 0 notify. Okay, let's have a watch on this one. So put a watch here. Okay. So here I have a watch. See, here's my test. It's 0 notify. Let's have a tailf here, because my scripts use the logger command to log what is going on. So we'll write just zeros in the volume. So the dd command, dd input file, output file, block size. So see, here I have a lot of signals and go there. You see, 0, 0, 0, it's expanded. See, let's do test 1 like this. See, I add 0, 0, 0, 0, 0. Each time I have a write in this zone. And when it's finished, I will just add 0 and not notify. So each time I will have the 0 added. See? No, this is a simple example, and you see when I reach the max is it's 500 megabytes. I have only 0, and the DD here stops. See, and it's done. The table is created in the user space, and the script. I keep the script as simple as I could for the example, but in a real script we can merge. You see, we can merge the 0 in 1, 0, and so on. We can do or make an optimized table. We can try to do it without fragmentation, without. So, you see, we don't have to do this thing in the kernel and have something very complicated like the DM thing. We can have a simple snapshot. We can have, for example, we can move. If the VM grow out of the space we have in the host, we can move it in somewhere we have placed in the cluster. See, it will be live storage migration, and it will migrate in another host. We can, for example, charge customers for space they really use. For example, I have a cloud, and people will buy VMs with, for example, unlimited space or 1 terabyte of space. But if they use only 10 gigabytes, they will pay only for 10 gigabytes. And if they use more, they will pay for more, and so on. The team provisioning is not implemented like this. This is a simple example. There is many ways to do it. The best way to do that is to have a snapshot and grow the code device. See, in the code device, we put notify at the end, and when the kernel itself tries to write into the code device, into the end of the code device will be grown by a user space process, for example, script or something like that. So this is the simple idea I had, and it wasn't so easy, because do something easy is very complicated. So this idea, we use it in the project we have. It's called EVKey, and it's a virtualization solution like Arash EV or Proxmox. We have a lot of work in it, so it can be expected in a month or two. I don't really know, because there is a lot of work in it, and it works without shared storage. VMs, when comes out of space, they are migrated, live migrated, and snapshot are very really very yeah, we do snapshot in a very short time, not like what we have in Red Hat or Proxmox. And yeah, if you have questions, yeah, just ask them. Yeah, slowly if possible. Yeah.
How fast, in terms of performance,
Yeah.
does it compare to the VM thin?
Yeah. How fast? When you try to use the DM notify, you have to know the size of each grow. You see, each grow, you have to know that it depends on what you intended to do with the storage. So it's the same with DMT. You have to know which the size you will use for the data blocks. So yeah, if you use big blocks, if you have, for example, a VM that grow very fast, the storage grow very fast, you can just use growth size, for example, 1 gigabyte. So the notification will be each 1 gigabyte. So you will have a very good performance and no fragmentation. See, yeah. This answer your question?
Well, I mean, if I were to resize on a similar situation, would yours be faster or slower?
Yeah, if you use the same size,
Yes.
yeah, I didn't have enough time to benchmark that, but because what I've showed is on EVKey, and I didn't compile the thing in the kernel, so. Yeah, I've tried to do it yesterday, but I didn't have enough time to recompile, and you see, so. But features or things you can do with DM Notify can do a lot of things, not like the DM10, and DM10 is limited in 60 gigabytes, so I think it's a better solution. It's simpler, and you can do something complicated or something optimized in the allocation. So when your process is notified, it can do something very complicated to keep everything not fragmented, and you see. Yeah, it's a kernel model. Yeah, you have to load it. So.
Like, is it in the public?
No. DM Notify is a kernel model.
Right. Is it in the Linux Linux?
In the mainstream of the kernel? No. It's something I've developed, and Yeah, you'll find it soon in the ifkey.org website, so you can download it, download the ifkey. I've told you it's a lot of work, so we have perhaps 1 month, or perhaps 2, I don't know. And yes, and it's a system we built from scratch, so it's not a fork from, Proxmox or Red Hat. Yeah.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and then fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication from Wicked.